Okay, so let's go to the different FBD of the mechanical systems presented. So this is important because we will be going into the parallel force system and the non-concurrent force systems. But for now we'll be dealing with the parallel system first, and then afterwards on Thursday we'll be dealing with the non-concurrent forces. So for number one, this is the plane truss. So as you can see in the diagram, so this one is a hinge. So usually if you have a hinge support, it will give you two reactions. You have the horizontal reaction and then the vertical reaction force coming from that hinge support. Now, now the other one is a roller support. So this one is a roller. So this is just a one vertical reaction support. So that's why it only has a vertical component. Then you have the external force P. So this is the external force. So usually our reactions coming from the hinge and the roller supports. So these are what you call as internal forces, meaning they are not. It's not really directly applied to the system. It's internally applied. Okay, so those are the the internal forces. So next is we have a cantilever beam. So we have three forces here. So it could be vertical or it could be diagonally applied. And in most cases, in the design of your beams and slabs later on, so we'll include the mass of your beam also. So it could be in a steel format or it could be in concrete. So, di ba, ang mga uso ron sa mga 21st century na mga designs is steel decking. So, of course, when we try to design buildings, so, apel po na siya ang weight sa dead weight, di ba? Or the weight of the material, or usually what we call as dead weight or dead load. Okay, so these are the external forces, meaning they are para makita ra, di ba? So, muna siyang F1 to F3. Now, the weight and the reactions are internal forces, meaning it is not directly applied, but it is internally present, di ba? They are present in the system. Meaning if you have a cantilever beam, so usually the support here is fixed, but it may be welded, it may be bolted, basta ang iyahang connection is fixed. And then usually if you have fixed nga mga supports, so we're going to have three types of reaction forces. So muna siya. So one is vertical reaction, horizontal reaction, and the moment. So na moment because di ba mura siya. So if you imagine this as a diving board, mura man siya mo-bend, di ba? So there's a moment there created. Okay, so we also have a beam. So again, if this one is a hinge support, it's going to give two reactions. And then of course, you're going to include the weight of the material as well. And notice that there's a vertical perpendicular force at this point A. So that will be a reaction coming from that point. Diba? For every reaction, third law of Newton, for every reaction, there's an equal but opposite reaction. So that's why there's a reaction force at that point. So roller here, then hinge. So notice that it's for roller one vertical load. For hinge, that will be horizontal and vertical. Okay, so categories of your bodies in equilibrium. So what we have discussed so far is that if you have collinear forces, meaning let's say you're only dealing with horizontal forces, so you're going to use one independent equation, which is the summation of forces x. So let's say your collinear force is in the y direction, so you can also use horizontal, the summation of forces y equals 0. So meaning since the direction of your forces is only in one line of action, it could be in the horizontal direction or vertical direction. So you're only going to use one equation only in this aspect. Okay, so I think last meeting we have discussed the concurrent forces at a point, or the equilibrium um, system of a particle, diba? So at that moment, we used two types of equation. So I think this one was also present in your exam, but dili lang siya equilibrium, di ba? So you also use these equations, but dili siya equal to zero. Equals to something else lang siya. Bakay dili man nato i-balance ang system. So that's why during the midterm exam, the summation of forces x is equal to something yun siya, dili siya equal to zero. So balik isago lang vertical and mga vertical upwards and downwards, then horizontal left and right. And whatever the resultant is muna siya ang inyong resultant force. So there is what a resultant force because the system is in equilibrium, di ba? Zero ang atong resultant. Okay, so here is we're going to use two forces, two equations. So horizontal and then vertical. So for our topic today is we're going to discuss this one, the third one, and that will be the parallel force system, the equilibrium of parallel force systems. And what we're going to use here is it could be the summation of forces x equals 0 and the moment, or the summation of forces y equals 0 and the moment. So it could be this pair up, two equations, or it could be this pair up, two equations also. So for parallel force systems is we're going to use two equations only. So for general force systems, so let's say bisag asa na padung inyong mga forces, it's a combination of parallel, concurrent, non-concurrent. So this is the time that you're going to use three equations to solve the equilibrium system. So here is three equations. And that will be on Thursday. Non-concurrent forces. Okay, so we have four categories. So I think categories 1 and 2 has already been discussed katong equilibrium of a particle. So we'll proceed to category 3, which is your parallel force systems. So this requires one force equation in the direction of the forces. So it may not only be exclusive to the x direction, so it may be the y direction as well. And of course, we're going to use one moment equation. So moto ganina on the previous slide, so it was the summation of forces x equals 0, and then the summation of moments z is equal to 0. So meaning one equation coming from your direction of the forces, and then one moment forces. So again, it could be in the y direction as well. So it could be either of these two equations that you're going to use. Solve for the equilibrium parallel force systems. Now for category 4, which is on Thursday, so this is the general system of forces or the non-concurrent forces. So this will require us to use the two directional forces, x and y equations, and then one moment equation about an axis. It could be the y-axis or it could be the x-axis depending on the problem. So muna siya for okay, so at this point, let's try to solve example number 1 first. So let me set up for a while. Okay, so for number 1 is we're going to pamakitaan ko ano. Okay, so since we're about the parallel force system, so let's try to solve the reactions. So I think that will be the important part on this topic. So we'll just be solving reactions. And then ano siya, since we'll solve the reactions nga makanegate sa mga vertical forces going downwards. Ano siya nga itong i-solve. Okay, so determine the reactions R1 and R2 of the beam in the figure loaded with concentrated load of 1600 pounds and a load varying from 0 to an intensity of 400 pounds per foot. And the second example is we're going to solve the reactions at A and B given this beam with a 2,000 pound force and a moment of 4,800 counterclockwise. Okay, so let's solve first number 1. So concentrated load, meaning this one, the 1600 pound force. And then your load varying from 0 to an intensity of 400 pounds. So this one is a triangular load. Triangular load. So meaning this one is from 0 going towards the 400 pound intensity. So notice that the load is 400 pounds per foot. The concentrated load is already in pounds. So the intensity load should be converted into a force or into a load. So how do we do this? So take note or take notice in the unit given, that's pound per foot. So upon conversion into its pound unit, so all you have to do is you have to multiply this one with the distance. Diba? So let's say your 1600 is your force number 1. And then to solve for force number 2, so that will be the distributed load, the unified, so it's the distributed load or the varying load. So how do you solve this is you're going to solve the area of this loading here. So how do you solve this one? That will be 1/2 base times height. That's the area of the triangle. So 1/2, that will be the distance, the base. So 12 foot. And then the height is this triangular load, 400 pound per foot. Ba? So notice that we can cancel out the foot unit. And what we have now is, so pasensya na kayo sa mayro kay mga ihasin ng mga tao mayro naman. Okay, so force number 2 is 2,400 pounds. Okay. So since we have this force as 2,400, so we're going to determine the placement of the force. So usually, diba, I think you have the topic of centroid. So for example, the center of a square is at h/2, diba? Na dire ang weight. Then for triangle, it's h/3, diba? So na dire. So H over 3, so mean or B over 3. So that will be on this area. So let's say this is the area of your 2400 pound force. And one third of 12, that will be 4. So meaning this is the 4 distance. And then the remaining distance here is 8. So just try to look up on this on the internet ang mga center of gravity of the different polygons. So for rectangle, H over 2, B over 2. For triangle, H over 3, B over 3, so on and so forth. Nana siya sa internet. I think nana siya sa yung geometry before if you have in high school. Or maybe senior high, basta na siya nga topic. So if we're going to draw again our system, so ito lang siyang ikaw na. Ito lang siyang isumpay lang. So this will be the 2400 force. And then this is the 1600 pound force. So ito lang i-con be. Okay, solid ang ito ang figure. Okay, parang mauota sa inyong mga drawing. Okay, so of course we're going to look for the reaction at A and R1 and R2. Okay, so since we have two unknown vertical force and then so this is 4, this is 8. So kani siya is kuha na siya 9. Baka 8 plus 1 is 9 and then this one is 3. So 3, 12, 16. So sakto ra 16. 3 plus 1, 4 plus 12, 16. So 3 plus 9, 12 plus 4, 16. So sakto ra to ang distance. So how do we equate our, or how do we solve first one reaction? So we're going to use first the summation of moments at one point equals 0. So how we're going to do this is we're going to either be taking moments from reaction 1 or from reaction 2 kung asa nyo ganahan. Pero pareha na siya ang labas na answer later on. Okay, so let's say we're going to take the moments at reaction 1. So meaning na dire yung point na moment. So the first moment created is from the 1600 load. So notice that the distance times the force 1600 will create a clockwise rotation. So di ba basta clockwise rotation, it will be negative, di ba? So meaning negative 1600 times 3. Okay? So next is 12. So the distance is 12 going towards 2400 pound force coming from R1. So this point is it's going to create again a counterclockwise. I mean a clockwise rotation. So meaning that's negative again. So 2400 times 12. Okay, and then lastly is your R2. So notice that in R2, it's going to create a counterclockwise rotation. Diba? And that will be 16 ang distance going towards the reaction 2. So plus R2, the unknown distance, and then the distance is 16 equals 0. So notice that the only unknown force here is R sub 2. So you can use your calculator in solving this one. So the reaction of the second point is 2100 pounds. Okay. So to solve for the reaction one is this is the time that you're going to use the vertical, the summation of vertical forces is equal to 0. So vertical force or summation forces y equals 0. So starting with R1, so since it's upward, it's positive force. Then minus 1600, that's downward force. Minus 2400, that's downward force again. Plus the upward force of the second reaction, 2100 equals 0. So notice in this equation, only one variable is unknown. Okay, so 1600, then 2400, then 2100. So reaction 1 is 1900 pounds. So this is how you solve your reactions in this problem. So do you have questions? Okay, so naray questions so far or clarifications? Hello? Hello? Okay, sige. So no questions so far. Okay, so let's proceed with the second example. So kadali lang ah. Okay, so let's proceed with the second example. So still on the parallel force system, but this time we're going to solve again reactions from A and D. So point A and then point D. So since the forces are just concentrated and we have one moment force here. Hello? Negative. Unsa may negative? Unsa man ang negative value? Dili siya negative because diba equal to 0 man siya, diba? So mahimo siyang R1 then minus 1900, diba? Equals 0. So transpose sa other side, so mahimo siyang R1 equals 1900 pounds. So naka-equate lahat sa left side pa. Then you transpose on the right side to isolate the unknown parameter. So I think that's the same as kaning sa inyohang moment from R1. Yung marang ako lang siyang nadiretso lang because I'm using shift solve sa calculator. But if you want to kuan lang, do it manually ka na lang para sure in yung answer. So ana lang siya. So first is moment and then the vertical reaction. Vertical force na summation. Okay, so again, what we need to do first is we take moments at a certain point. So it's best that you take moments from an unknown parameter para ma-eliminate siya during the taking of moments, diba? So let's say we're going to take moments from D na pod on the right side. So moment at D equals 0. So starting from A, so reaction at A, so the distance going to reaction A from point D is 12, diba? 12 feet. And the moment it creates is clockwise, diba? Clockwise. So meaning that's negative. So negative reaction A times 12 feet. So next is the 2,000 pound force. And the distance going towards the 2,000 pound force coming from point D is 9 feet. And if you're going to push this force, so meaning na ang yung moment na ma-create is counterclockwise. And that will be a positive moment. So plus 2,000 times 9 feet. And then lastly is we have a positive, a counterclockwise moment that is positive. So meaning that will be plus 4,800 pound-foot. So di na siya i-multiply yung distance because it's already a moment, diba? So we just have to add that in the system. And then equals 0. Okay, so this will be negative 12 RA and then plus 1,800 plus 4,800 equals 0. So by this time, you can now solve the reaction at A, which is equal to so the reaction at A is 1,900 pounds. Okay, so next is we're going to use the summation of forces vertical, diba? One directional force equation, and that will be in the y direction because our parallel force system is in the y aspect. So summation of forces y equals 0. So starting with, so we can go from left to right. So RA going upward is positive, then minus 2,000 pounds negative downward. Diba? Ang moment, ang 4,800 na moment is we can just ignore this one because this one is a moment. This one is not a vertical force. So you can skip that one. You can skip the 4,800 moment because it's not a vertical force. Then plus R sub D equals 0. So coming from your R sub A, so that will be 1,900 minus 2,000 pounds plus R sub D equals 0. So this will be negative 100 pounds plus R sub D equals 0. So R sub D equals 100 pounds only. So again, what we did is we used one moment equation and then one directional force equation. So it could be the vertical direction na equation or the horizontal component depending on the problem. Okay. So take note that if you add up RA and RD, that will result to the 2,000 pound force. So meaning it's in equilibrium. About 2,000 upward against 2,000 force downward. So quits lang sila, diba? Quits lang. Okay, so questions for this? Hello, questions? Hello? Okay, so klarong-klaro. So we go to the last example. So let's say nagpatong-patong na ang mga beams ninyo. Okay, so you have a beam. So this one is hinge. This one is roller. This one is roller. This one is hinge. So how can you detect if this one is a hinge and the other one is a roller? So for roller is inanin siya ang mga figures for roller. For kana mga, let's say it's just a parang bola lang then beam. So pwede po siya basta na yung mga circle or parang curve shape na figures, that is a roller. For hinge support, so usually inani bolted, and then it could also be represented by a triangle if mga hinge. Okay, so again from what I have discussed earlier, if hinge, two supports, roller, one support, this one is one also, and hinge is two supports. So since we don't have any horizontal forces present in the system, as you notice, puro siya vertical load, all of which are vertical loads. So meaning we can declare that the horizontal component of the hinge supports are equal to 0. So if you're going to ask me when will that be available nga na siya horizontal component, so that's what we'll be discussing on Thursday. So you'll be dealing with X and Y forces na for your system. Okay? So let's try to figure out this one. So which is better for you, to solve the first beam or for you to solve the second beam? So if we're going to analyze this separately, so if we're going to separately analyze, let's say, the beam of CD. So pasensya talaga sa drawing. Kaya marag bati jud siya i-drawing sa kuan. Graphic tablet na gani ko, bati pagyapon. Okay, so this one is the 60 kilonewtons and then this is the 190 kilonewtons. And this is the reaction at C and then reaction at D. So this one is 60 kilonewtons, 10 meters, and then 190 kilonewtons, 4 meters. So if we're going to compare this FBD of beam CD against the other beam AB, so ano lang ato lang inanang drawing. Okay, so this is the 400 pounds. Kilonewton, I mean. This is the reaction coming from A. Then this is the reaction coming from B. And notice since the reaction or the roller C is on top of beam AB, so meaning it will create another force here, unknown, diba? So if we're going to compare the force body diagram of the two beams, So in beam CD, you're only going to be dealing with two unknowns. Diba? But if you're going to analyze beam AB first, you're going to be dealing with three unknowns. Diba? And again, as per what we have discussed earlier, diba? Since we are solving parallel force systems, and since we're only allowed to use two equations, so meaning since you are only given two equations, we can only solve two unknowns at the moment because mo na siya mag-reflect man na siya sa number of unknowns ang number of equations. So if you have two equations, you can only solve two unknowns. If you have three unknowns, you're going to use three equations. So ano na siya. So since we have to solve first this diagram, kani siya. Okay, since we're only be dealing with two unknowns, so let's say we're going to take up moments at point C, diba? Is equal to 0. So going towards the 60 kilonewton force, that will be a counterclockwise moment, diba? Coming from C, and the distance is 4 meters. So since counterclockwise is positive, so that will be 60 times 4 meters. And the next is the 190 kilonewton force. So since it's on the right of point C, so it will create a clockwise rotation. And this will be negative. So negative 190. Then going towards that distance, so 4 minus 10, that will be 6. Or 10 minus 4, that will be 6. And then lastly is the reaction coming from point D. So from point C going towards point D, that will be 10 meters. And then the rotation it will create is counterclockwise. So that is positive force. So plus RD is equal to RD times kwan pa day? RD times 10. So RD punch-up equals 0. Okay? So that will be 240 minus 1140 plus 10 RD equals 0. So 240 minus 100, 1140, that will be negative 900 plus 10 RD. So you have 10 RD equals 900. So divided by 10, so RD is 90 kilonewtons. Okay, the next is summation forces Y equals 0. So from left to right of beam CD, so negative 60. And then the reaction at point C, and then negative 190. Then the reaction at point D equals 0. So you have negative 60 plus the unknown reaction at point C minus 190 plus 90 equals 0. So reaction at point C, that will be 160. Sakto ba? 160 newtons. Kilonewtons, I mean. Okay, so since on beam beam CD, the reaction of C is going upward, 160. So if we're going to convert that one on beam AB, so since beam CD is on top of beam AD, so meaning it it's creating somewhat of a weight, diba? So parang weight yung function ng point C at beam AB. So if this one is upward, so upon translation going towards beam AB, so this becomes a downward force since it's on top of beam AB. So this is 160 kilonewtons. So at this point, since we know the reaction as 160 kilonewtons, and observe that we only have two unknowns now, the reactions of A and B, so we can now analyze this beam right now. Okay, so the same procedure is we're going to be taking moments first. So let's say at point A baron equals 0, and then okay, so 400 kilonewtons from point A, that's 4 meters, and it will create a clockwise rotation. So that will be negative 400 times 4. Then going towards the reaction at B, that will create a counterclockwise rotation. That's positive. So R sub B times 10. And then the reaction at point C, that is downward. And thus it will create a positive clockwise, a clockwise rotation, and it's a negative moment. So negative 160 times 14 equals 0. Okay, so negative 1600 plus 10 R sub B, then minus 2 to 40 equals 0. Okay, so that will be 10 RB minus 3840 equals 0. So you have 10 RB equals 3840. So reaction at point B is 384 kilonewtons. Okay, and then lastly is summation of forces Y equals 0. So from left to right, that will be reaction A upward, positive. So pasensya na sa aso, okay. So minus 400 kilonewtons, that's downward, plus an upward reaction force coming from B, then minus 160, yung nagpatong na force at point C, di ba? Or the roller at point C. So since it's on top of beam AB, so it will make a weight reaction, di ba? Equals 0. So R sub A minus 400 plus 384 minus 160 equals 0. So since there's no space, so let's try to solve RA immediately. RA is equal to 176 kilonewtons. Right? So what you need to do in your parallel force system is, number one is use the moment equation first in solving one reaction, and then to get the other reaction is you're going to use summation forces directional. It would be up, or it could be the horizontal component equals 0, depending on, again, the problem that you are presented with. Okay, so questions or clarifications regarding the topic? Hello, hello. Hello. Okay, so how do you know if one is counter and the other one is clockwise? So good question. So, let's try to go back on this figure lang para mas klaro. So the rotation of your forces will depend on the point that you are going to take your moments from. So earlier I took moment from point C. Madire. So again, the equation for moment is force times distance. So in physics, it is torque, di ba? Force times distance. So from point C, going towards 60 Newton force, di ba? So ako lang siyang i-extend so that you can namoy visual representation of the moment arm. So the moment arm is 4 meters, di ba? So if you try to push 60 newtons with this distance, so di ba, it will turn on this direction. That's counterclockwise. Now, if I'm going to push the force using the distance, ba? So that, let's say 6 meters. So the rotation is, pardon, dire, di ba? Clockwise rotation. So let's say in the reaction, so let's try to extend so that we can visually present the moment arm. So this one is 10 meters. So if you're going to push the force using the distance, so it will turn to the left, diba? So meaning it will create a counterclockwise rotation. So counterclockwise is kanang the opposite of clockwise, diba? Obviously. Diba clockwise kanang magtuyok inyong oras, inyong watch, diba? That's clockwise direction. Counterclockwise is the opposite side. So marag ang tip ana is i-draw lang ninyo o extend lang ang point that the point where you are referring your moment. Then let's say you try to push the bottom part of the force with a distance. And di ba makibaba mo na if kung asa ka dong. So let's say na may ball pen, then you're going to push it on the left, di ba? So let's say na may ball pen, you're holding it on the right hand, then you're going to push it with your index finger using your left hand. So marag ang rotation is going to the left, di ba? So that's clockwise direction. So if I'm going to hold it on the other hand, let's say the left hand, and I push it with my right index finger, so the direction will be counterclockwise. Marag-ana ra siya. So I think it's best that you have two ball pens on your home. I-push-push lang ninyo na. Kung siya mo rotate, is mo to siya ang rotation sa inyong moment. Clockwise or counterclockwise. Okay. So I hope I answered your question. Okay, so questions, any further questions? Okay, so if there's no more questions, so I think that's it for today. And we'll meet again on Thursday for the topic on equilibrium on non-concurrent forces.